All right, we're going to move on with our discussion of Chapter 21, and we're going to talk about some properties that curves have. Maybe you're given a function and you want to know what the graph looks like, but you don't have a calculator handy, so you may need to just learn some things about the curve so that you can sketch it a little bit accurately. One of the things you might want to know about a curve is where is that curve increasing? In other words, where is the function having slopes that are positive? So in other words, it's just kind of going up like that. And where is the curve decreasing? So like from here to here it would be decreasing. And then once I start over here, it's increasing again. So where does it do that? Where does it increase and where does it decrease? Well, that all relates back to the derivative. So if I take the derivative of this, I'm going to call it dy dx. You can call it y prime, or you can call it f prime of x, whatever you want to do. But we do it the same way that we've always done it. The derivative of 1/3 x cubed is going to be x squared. The derivative of -1/2 x squared is just going to be x. And then the derivative of -2x is just going to be -2. All right, so that's the derivative, and sometimes it's positive, and sometimes it's negative, and sometimes it's 0. So when this function is increasing, this derivative, x squared minus x minus 2, is positive. And when this function is decreasing, this expression, x squared minus x minus 2, is negative. So I want to know where those intervals are. Well, notice that when it switches from being increasing to decreasing, there's a moment right here where the slope of the tangent line would be 0. And same thing down here. Right before it switches from decreasing to increasing, there's a moment right here where the tangent line will have a slope of 0 again. So these 2 points right here, where the slope is 0, are going to help me break up this graph into the 3 intervals where it's increasing and then decreasing and then increasing again. So if I set the derivative equal to 0, that's going to help me find where these x's are, even though it's probably kind of obvious from the graph. It's not always obvious from the graph. Ignore this stuff down here. That was a previous example that did not work out for me. So I'm going to factor this, or if you couldn't factor it, you would use quadratic formula or whatever you wanted to use. Okay, so it factors into x minus 2 times x plus 1 equals 0. All right? And so the points where the derivative is 0, meaning that the tangent line would have a slope of 0, are x equals 2 and x equals 1. Okay? And you can see that it's increasing before you get to x equals -1. It is decreasing between -1 and 2, and then it increases after 2. But let's say you didn't know that. What you would do is you would make a sign diagram. All right? And the two, -1. The 2 spots where the derivative is 0 are at -1 and 2. So let's talk about what's going on before -1. I would just take some number that's less than -1 and plug it into the derivative. I would actually plug it into the factored form of the derivative just to see whether each factor is positive or negative. So if I take, say, -5, -5 minus 2 is negative. -5 plus 1 is negative. So I've got a negative times a negative, which is positive. So the derivative is positive everywhere before -1, meaning that the function itself is increasing. Now if I look between -1 and 2, so I can pick my favorite number in that interval, which is 0. 0 minus 2 is still negative, and 0 plus 1 now becomes positive. So a negative times a positive is negative, meaning that the derivative is negative everywhere between -1 and 2, meaning that the original function is decreasing. And then if I want to look at my last interval, which is everything bigger than 2, I can pick a number that's bigger than 2, like 3. And 3 minus 2 is positive. 3 plus 1 is still positive, so I have a positive times a positive, which is positive. That means that the derivative is positive everywhere after 2, meaning that the original function is increasing everywhere after 2. And that's exactly what this graph shows. So we're going to be doing more questions like that tomorrow. Feel free to email me any questions that you have, and we'll work on this tomorrow. I'm breaking up this section into little itty-bitty pieces so that we can get a really good understanding of it. So the lessons will be shorter for the next little while.